If equilibrium constant of a reaction is 2.5 into 10 to the power minus 10, then at equilibrium system will contain mostly product, mostly reactant, only product, or the equal amount of reactants and the product. Simply, we should always know that equilibrium constant determines the extent of reaction also. It clearly tells us about the extent of reaction, how much reaction has occurred, or how much amount of product is left, or how much amount of reactant is there. We can have an idea about that using equilibrium constant. So if the value of equilibrium constant is high, it represents that reaction is about to complete and extent of product is very much. But if we talk about that equilibrium constant which is very less, that represents that reaction is yet to start or very less amount of product is formed there. It means mostly reactant is present there. So if we look at this given value, that is 2.5 into 10 to the power minus 10, this is quite low value. And it represents that at this state, system will contain mostly reactant. And that's why I'll choose this as the correct option. Now after this, it's a turn for question number 62. Degree of hydrolysis for a salt of weak acid and strong base can be changed by. Different options are given here. So we should always know that whenever we talk about the KH value for the salt of weak acid and strong base, that is equal to KW by Ka, because we're talking about the salt of weak acid and strong base, and that is equal to C H square by 1 minus H. Now, increasing concentration of salt, the first option it is written, if you increase the concentration of salt, in that particular case, the H value would be decreased. With the help of the formula, you can easily identify. Further, increasing temperature. If you increase the temperature, definitely in that particular case, this Kw value and Ka value would be changed, and definitely degree of hydrolysis would also be changed. Adding a base. If you add a base, due to the common ion effect, definitely the H value would be decreased. And if it is so, the first three options are correct, and simply we can say the fourth option is absolutely correct, which states all of these are correct. And that's why I'll choose option 4 as the correct option. Now, let's take question number 63. pH of aqueous solution of salt, ammonium carbonate, will not depend on. If we talk about this salt, this is ammonium carbonate, and it's a salt of a weak base, NH4OH, and weak acid, that is H2CO3, carbonic acid. For this case, the pH value can be calculated using the formula 7 plus half pKa value minus half pKb value. This is the formula. And if you look at this formula, you will identify that this pH is concentration independent. But it can be changed by change in temperature. It also depends on ionization constant of NH4OH and ionization constant of H2CO3. It means in this particular case, the concentration does not have any effect on the pH, and that's why the correct option is option 3. And after this, it's a turn for question number 64. If solubility is of a sparingly soluble salt, that's AgCl in pure water, in 0.1 molar HCl, in 0.2 molar AgNO3, and in 0.1 molar ammonia respectively are S1, S2, S3 and S4, then the order of solubility is. So in this case, the first thing that we have here is AgCl, and you're just going to dissolve it in different solvents. First you have taken the pure water, and when you dissolve this in pure water, the solubility is found to be S1. Then you dissolve it in 0.1 molar HCl. Then the solubility was found to be S2. In third case, there was 0.2 molar AgNO3, silver nitrate you have taken, and here the solubility is S3. Next, you have dissolved it in 0.1 molar ammonia, and in this case, the solubility was found to be S4. And the question is that you just have to arrange these solubility in the order of increasing values. So one thing you should always remember, then when you dissolve certain salt in a certain solvent and it is forming there a complex, definitely in that case the solubility is maximum. So when you dissolve this AgCl in ammonia, there is the formation of a complexed salt, and salt is ammonical silver chloride, and due to which the solubility is maximum in this case. So S4 is maximum. Then if we talk about pure water, that is neutral, solubility would be less as compared to this. But if we talk about S3, AgNO3, you are dissolving this in silver nitrate. Due to the presence of common ions, definitely the solubility would be decreased a lot. And due to that, we can say that this S3 is the least one. So here's the turn for S1. You are dissolving this AgCl in water, in pure water basically. Solubility would be quite high, but due to the presence of common ion in HCl and AgNO3, the solubility is less. Now in these two cases, you have taken more concentration of AgNO3. That is why the solubility is least in case of AgNO3, because more effective common ion would be there. But in case of HCl, the concentration is 0.1 molar. That's why after S1, the solubility is there in case of 0.1 molar HCl, and for that it is S2, and the last is for 0.2 molar AgNO3. For this, the solubility is S3. On the basis of this, the correct option is option 3, and I'm choosing it as the correct option. Now, after this, question number 65 is here. The delta G naught value for a reversible reaction at 25 degrees Celsius, whose K equilibrium is given, that is 10. So basically, you just want to find out the delta G value, delta G standard. We can relate it with the equilibrium constant, that is equal to minus 2.303, a very common formula, RT log K equilibrium constant basically. So it would be 2.303 R. What's the temperature? That is 298, because we are considering the standard condition, and log 10. K equilibrium value is given in the question. So this is equal to minus 2.303 R into 298. And what's the value of log 10? That is 1. And that's why this is the answer. Let's check where this answer is given. This is given in option 3. And yes, it is the correct answer for this question. Let's take question number 66.